Dear children, today we are going to discuss about one important concept, that is basic proportionality theorem in the chapter triangles of class 10th. Basic proportionality theorem, and this theorem is also known as Thales theorem. It is proved by great mathematician Thales. So what is this basic proportionality theorem? If a straight line is drawn parallel to one side of a triangle intersecting the other two sides, then it divides the two sides in the same ratio. This is most important. In a triangle, if you draw a line parallel to one side, that line divides other two sides in the same ratio. That is basic proportionality theorem. We will prove this. Here, ABC is a triangle, and this line L is a line. This line L is parallel to BC. Line L is parallel to BC. This line intersect AB at point D and intersect AC at E. That is given. So while proving a theorem, we follow some steps. First we will take what they have given. So we call it as given. Afterwards, what to prove? We call it as to prove. And next, for proving a theorem, sometimes we need some constructions. So for that we take constructions, additional information. To get information, additional information, we do constructions. Next, we start proof by using all this. So here, we are given a triangle ABC in which a line L parallel to side BC intersects other two sides AB and AC at D and E respectively. So at D and E it intersects. Now we have to prove that AD by DB is equal to AE by EC. That means AD, this side, this part AD by DB is equal to AE by EC. We have to prove. To prove that, we need some constructions. Here we construct. We'll join B and CD. We join this point B and E and point C and D. And next, one more important construction is we draw DF perpendicular to AC and EG perpendicular to AV. DF, from D we draw a perpendicular to AC, that is DF. From E we draw a perpendicular to AB, that is EG. These are the constructions. Now we are going to prove it. To prove this theorem, we take the concept of area of triangle. In class 6th or 5th onwards, we have been doing or using this area of triangle. In general, area of triangle is half into base into height. Half into base into height. Here, if you consider this triangle ADE triangle, in this triangle ADE, if you consider this AD as base and this EG will be corresponding height, EG will be corresponding height. Therefore, area of triangle ADE is equal to half into base into height, that is equal to half into AD into EG. Base AD and EG is height. But we know that in the lower class we have discussed that to denote area of any triangle we use AR. For area of triangle ADE, we denote AR of triangle ADE. While writing we write it as AR, but by pronunciation we pronounce it as area. So area of triangle ADE is equal to half into AD into EC. Next one. Next, we will find the area of BDE. BDE. If you observe this triangle BDE, this is an obtuse triangle. This angle, if you observe this angle is more than 90. So obtuse triangle. So here this EG will be the height of this BDE also. So if you want to find the area of BDE, if you take this BD as base, then this EG will be the height. Now area of BDE is equal to half into BD or DB into EC. That is area of triangle BDE. Next, again area of triangle ADE. Area of triangle ADE. Here already we have found this area. Now we are going to find this area of triangle ADE by taking AE as base. And when we take this AE as base, then this DF will be the corresponding height. DF will be the corresponding height. In such case, area of triangle ADE is equal to half into AE into DF. AE is base and DF is height. And similarly, if you want to find the area of triangle DEC, this also obtuse angle, angle DEF, DEC is obtuse angle. So area of DEC, if you want to find, if you take this EC as base, then this DF will be the height. Therefore, area of DEC is equal to half into EC into DF. Now we have found 4 areas. We have found this area of ADE in 2 ways, by taking AD as base and by taking AE as base. Next, area of BDE we have found, and the area of DEC also we have found. Now let us consider the ratio area of triangle ADE by area of triangle BDE. Area of triangle ADE by BDE is half into AD into EG when we consider this area as base, and the area of BDE is half into BD into EG. But here, if you observe, half get cancelled and EG get cancelled, we will get AD by DB. We will get AD by DB. Next, again, let us find the ratio of area of ADE by area of DEC. Here area of ADE, here we consider this AE base. In such case, half into AE into DF by half into EC into DF. Here also half get cancelled. DF get cancelled. We will get AE by EC. AE by EC is right. So this AD by DB here, this call it as 1, and here this ratio call it as 2. Now if you observe this area of triangle AD by area of triangle BDE, and here area of triangle ADE by area of triangle DEC, in these 2 ratios the numerators are equal. Area of AD, here also area of AD. These 2 numerators are equal. Now let us find whether the denominators are equal or not. We will check. If denominators are equal, then this entire ratio, that is area of AD by area of BDE and area of AD by area of DEC, these 2 will be equal. When these 2 ratios are equal, then AD by DB is equal to AE by EC. Our theorem over. We will go to next one. Here, BDE triangle and DEC triangle. These two triangles are having same base DE. These two are having same base DE. And these two triangles lies between same parallels. Here DE and BC are parallel. So these two triangles are having same base and lies between same parallels. So when two triangles are having same base and between same parallels, those two triangles are equal in area. In class 9th we have discussed this concept. Therefore, here area of BDE and area of DEC, these two are equal. These two are equal. So that means here this denominators, area of BDE and area of DEC, these two denominators equal. So numerators are equal, denominators are equal. Therefore, these two ratios are equal. So therefore, from equations 1, 2, 3, what are those two equations 1, 2, 3? This equation 1 and 2 and this 3, we can conclude that AD by DB is equal to AE by EC. That means when you draw a line parallel to one side in a triangle, that line divides other two sides in the same ratio. By using basic proportional theorem, we solve a problem. This is not a problem, this is extension of basic proportional theorem. That means it is a corollary. It is a corollary. If a line intersects sides AB and AC of a triangle ABC at D and E respectively and is parallel to BC, prove that AD by AB is equal to AE by AC. So what we have proved in a basic proportional theorem, a triangle ABC and this D is parallel to BC, then we proved that AD by DB is equal to AE by EC. We have proved in basic proportional theorem. Okay, this one. In a triangle ABC, DE is parallel to BC by basic proportional theorem. AD by DB is equal to AE by EC. Or if you take the invertendo, when you take the invertendo, then this AD by DB is equal to AE by EC becomes DB by AD is equal to EC by AE. Just we take reciprocals. Reciprocal of this fraction, reciprocal of this fraction also equal. We call it as invertendo. Now for these fractions, let us add 1 on both sides. We add 1 on both sides. Then if we take LCM, here AD will be the LCM, and we'll get DB plus AD by AD, and here we'll get EC plus AE by AE. But what is DB plus AD? DB plus AD is nothing but AB. So this numerator is AB, and EC plus AE, EC plus AE, this is nothing but AC. So here this numerator is AC. Therefore, this is AB by AD is equal to AC by E. Again we take invertendo. Then we'll get this AB by AD becomes AD by AB, and AC by AE becomes AE by AC. So this is one corollary. Not only this, when a line is parallel to one side of a triangle, then we have AD by DB is equal to AE by EC, this one, and we can prove this BD by AD is equal to EC by AE also. So here while taking the order BD by DA, then this side also you have to take like this. You can take many orders. For example, here we have taken AD by AB is equal to AE by AC. One more I will take BD by AB is equal to EC by AC also happens when a line is parallel to one side of a triangle. This is about a corollary of basic proportional theorem. Next we are going to discuss another problem. Here you see, in the following figure, LM is parallel to CB. This LM is parallel to CB. And LN is parallel to CD. Then we have to prove that AM by AB, this AM by AB is equal to AN by AD. We have to prove this. We prove this by using basic proportional theorem. Here, in triangle ABC, if you consider triangle ABC, in this triangle, LM is parallel to CB. It is given. So that means in a triangle one line is drawn parallel to one side. Therefore by basic proportional theorem we will get AM by AB. We have proved in corollary. AM by AB is equal to AL by AC. AM by AB is equal to AL by AC. Let it be 1. Now in triangle ADC, if you consider this triangle ADC, in this triangle NL is parallel to DC. Again by basic proportional theorem, AL by AC is equal to AN by AD, or AN by AD is equal to AL by AC. AN by AD is equal to AL by AC. Now from these two equations, if you observe these two equations, here this RHS is AL by AC, here RHS is AL by AC. These two RHS are equal, therefore LHS also equal. That means AM by AB is equal to AN by AD. So like this we can prove or we can solve number of problems by using basic proportional theorem. Thank you.